All right, in this video, we're going to introduce the graphs of the sine and cosine functions. So we can graph sine and cosine functions much in the same manner we can graph any function. If we pick values for our independent variable, usually x, and evaluate the function, we'll get a y value. So pick inputs, evaluate the function, and get outputs. We can then plot those points and connect them. So for trig functions, if we let the x-coordinates represent the measure of the angle, and then let the y-coordinates represent the value of the ratio, we can plot the graph of sine and cosine. So we'll start with the graph of sine. And here we have probably around 20 or so points that we plotted and then connected them. So notice the sine function has this wave-like feature to it. The cosine function does as well. So with sine and cosine, we're going to have hills and we're going to have valleys. So we'll have relative minimum and relative maximum points on our graph. So in this video, we're going to focus on finding the amplitude of a sine or cosine function. And the amplitude of sine and cosine, and as well the amplitude for all the trig functions, is going to be half the maximum value minus minimum value. Now, bear in mind the maximum value and minimum value, we're referring to the y-coordinates or the outputs for the top of the hill and the bottom of the valley. So if we take a look at our graph, we see that the maximum value occurs at actually pi over 2 or 90 degrees. Sine of pi over 2 or 90 degrees is 1, and that's as tall as this graph is going to get for a maximum value. The minimum value occurs at 3 pi over 2 or 270 degrees, where sine of 3 pi over 2 or the sine of 270 degrees is negative 1. So for our value, our maximum value is 1, our minimum value is negative 1. So if we take 1 minus negative 1, we get 2, and then half of 2 gives us 1. So our amplitude for sine of x, as well as our amplitude for cosine of x, is 1. Now, if we want to change the amplitude, we need to either stretch the graph vertically or also compress the graph vertically as well. So recall that vertical stretches, and compressions for that matter, involve multiplying the function by a positive value, the entire function. Negative values, again, reflect the graph across the x-axis, so it doesn't change how far away those points are. So for the functions in the form y equals a times the sine of x or y equals a times the cosine of x, our amplitude is simply the absolute value of a. In other words, if we just have a number times sine of x or we just have a number times cosine of x, the amplitude is the absolute value of that number. So for example 1, we're going to look at the amplitude of each of the following. So we have 3 times the sine of x for example 1a. So if we look at what we have in front, we have a 3. So taking the absolute value of 3, it gives us 3. So in other words, we took our sine graph and stretched it vertically by a factor of 3. So now all points are 3 times as further away from the x-axis as they were before. Part B, we have y equals 5.5 times the sine of x. Our amplitude is the absolute value of 5.5, which is 5.5. So now, again, our points are 5.5 times farther away from the x-axis than they used to be. Part C, we have y equals 0.5 cosine of x. Our amplitude is the absolute value of 0.5, which is 0.5. So this is a vertical compression. Now our points are half their original height, which means they're twice as close to the x-axis. So it presses it downward, which makes our amplitude this time only a half. And finally, part D, we have negative 2 times the cosine of x. This time we have a negative out in front of cosine. That just flips the graph over the x-axis. Our amplitude, though, is the absolute value of negative 2, which is 2. So if we took our maximum value and minimum value for negative 2 times cosine of x, if we subtracted those maximum and minimum values and took half the result, we would still get 2, even though there's a negative out in front. All right, so that about does it for this video. Thanks for watching. I'll see you next time.